Morning. So today I'm going to discuss about the galvanic as well as electrolytic differences as well as similarities. So first, before I'm going to discuss about the differences or similarities, first you must understand what is a cell. A cell is consisting two components. One is the anodic component, another one is the cathodic component. Otherwise, you can call it as anodic half cell and a cathodic half cell. A cell is consisting of two half cells generally. A anodic half cell and a cathodic half cell. Two types of half cells will be present in any cell. Here, what is the anode and what is the cathode? For example, any electrode here I am taking one electrode. For example, zinc I am taking. Here I am taking the copper. Here I am taking the anodic salt solution that I am selecting the zinc sulfate solution I am taking here. Here copper I have taken as the cathode. So copper salt solution I am taking. Copper salt solution I am taking. And both the electrodes are connecting through the voltmeter to measure how many volts are generated by a galvanic cell. And to complete the circuit, I am connecting through a salt bridge. Both the electrolytes are connecting through a salt bridge. Here, this is a galvanic cell. And when you see electrolytic cell, both the electrodes are dipped in the same electrolyte. There is no separate electrolytes for the anode and cathode, and both the electrodes are connecting through the battery. This is the battery. Here, this is the battery. And if you see here, I can select this is the zinc is the anode, here copper is the cathode, and any electrolyte I can select, not only zinc salt solution or copper salt solution, different salt solution also I can select. For example, I want select sodium chloride as an electrolyte. Yes, I want check sodium chloride as an electrolyte. I want electrolyte, the electrolysis process I want to, and I want separate the molten sodium and chloride separate. I want to analyze ionization. I want to do it, and the electrolysis process I want to do it. So electrolytic cell I have selected. This is the electrolytic cell. This is electrolytic. Here electrolytic lytic means lysis, where the salts are they will electrolyze breaking into or ionizing into separate that separating into their ions, like sodium is ionized into Na plus, chloride ionized into Cl minus, where Na plus this is the positive charge and Cl minus is the negative charge here. So one more important point I want to tell you here, in the galvanic cell, anode is negative charge, cathode is positive charge. Here, so now here, whereas in the electrolytic cell, anode is positive, cathode is negative side, and here, how do you differentiate galvanic and electrolytic cell? Here, anode is negative sign is there, cathode is positive sign is there in the galvanic cell. This is the galvanic cell. This is the electrolytic cell. Whereas in the electrolytic cell, what happening? Anode and cathode both are dipped in the same electrolyte, as well as anode is the positive charge and cathode is the negative charge. Opposite charges are, you can observe here. And the differences you see here, in the galvanic cell, both the electrodes are connected to the voltmeter. Here it is connected to the battery. Here what happening? In the galvanic cell, the energy is producing. where the electrical energy is producing, whereas in the electrolytic cell, energy is consuming. Here, the galvanic cell is energy that electrical energy is producing, whereas in the electrolytic cell, electric energy is consuming here. Right. And you see, the here salt beach I am using here. Is there any salt beach are you observing? No salt beach here. Understanding? This is the here. The salt beach is not there. We not required salt beach also. Here, salt beach is required. One more important point. Here, I am taking the zinc is the anode and the copper is the cathode. And if I draw the cell diagram in the galvanic cell, if I draw the cell diagram like this, for example, I want to take the, for example, copper, I have taken the anode and zinc is taken as the, and here copper sulfate I have taken, and here zinc sulfate I have taken as the electrolyte, for example, in the galvanic cell. Is this correct diagram? No, this is wrong diagram. This is wrong diagram. Why? Because, okay, this is about the galvanic cell. This is the wrong. Whereas in the case of, here I am taking the copper and I am taking the zinc here. Is this wrong or right? This is the right diagram only in the case of electrolytic cell. But whereas in the galvanic cell only it is wrong. Why? Why? Because in the galvanic cell, anode and cathode will be decided based upon their SRP values, based upon the SRP, standard reduction potential values. Whereas in the electrolytic cell, we are not depending upon their SRP values to select anode and cathode. Here, any electrode can be selected as anode in the electrolytic cell. Any electrode can be selected as the cathode in the electrolytic cell. Whereas in the galvanic cell, not possible to select any electrode as the anode, any electrode as the cathode. You must select anode or cathode depends upon the SRP values only, which is having the lower SRP, that is anode. That is anode in the galvanic cell. And higher SRP is the cathode. Higher SRP is the cathode, lower SRP is the anode. Whereas in the electrolytic cell, we never depend upon their SRP values. Here, I am selecting the copper electrode to the positive terminal of the battery, then it will become the anode. I am connecting the zinc to the negative terminal of the battery, then it is the cathode. Here, in the electrolytic cell, anode and cathode will be decided based upon the electrode connecting to the terminal of the battery. If I connecting the positive terminal of the battery, then that is the anode. When I connect any electrode to the negative terminal of the battery, that is the cathode. Anode and a cathode, we never decide based upon the SRP values. Only we are deciding based upon the battery connected here, any electrode connecting to the battery. If I connect to the positive terminal of the battery, that is a negative terminal, that is the cathode in the electrolytic cell. So, whereas, and one more important point I want to tell you here, it may be electrolytic cell or galvanic cell, always anode should side to you. Here, this is my right hand side, so I am selecting here. This is the right hand side, so I am selecting the anode as the here. This is this side anode, this side cathode will be there. So SRP values point of copper SRP value is 0.34 volts, 0.34 volts. Here, this is the copper value, and minus 0.76 volts for the zinc here generally. So, which is the lower value? Zinc is the lower value. So, that is the anode only. Always, zinc should be anode, copper should be cathode. If you want to take in the galvanic cell. So here, that is the reason why this is the wrong diagram. What is the right diagram? Always, always zinc should be left hand side, copper should be right hand side. Thus, you must select the galvanic or electrolyte. Here, that is the here. This is the copper sulfate. This is the right diagram. Like this only must draw in the galvanic cell. That is very, very important thing while you are understanding the electrochemistry or to understand the galvanic cell. Whereas in the electrolytic cell, we need not bother about the SRP values. What electrode you are connecting to the battery, that depends upon the terminal of the battery only we are deciding. So this is important point. And how to represent the galvanic cell, that is a cell notation, how to represent the cell notation. For example, what electrode I have taken as the anode, zinc I have taken as the anode. So what happening in the, what reaction taking place at the anode? Oxidation reaction. At anode, always oxidation reaction only. It may be electrolytic cell or galvanic cell, whatever the cell may be, always oxidation reaction only. So zinc I have selected as the anode. So zinc plus 2 moles of electron. What is oxidation reaction? Loss of electron is called as oxidation. Zinc is the electrode where it is converting into 2 moles. Here 1 mole of the zinc plus 2 ions and 2 moles of electrons. This is the loss of electron reaction, and this is the oxidation reaction. And here copper I am selecting copper. Electrolyte is converting into copper plus 2 moles. So it gained the electrons too, and it is converting into copper metal. What happening in the galvanic cell generally? If you select here, if you see, zinc is losing the electrons, and then the electrons will go through the wire and then it will reach to the copper here. So copper, what it will do? Reduction reaction takes place at the copper, and the zinc oxidation reaction because of it losing the electrons. Here what happening? The electrolyte, in the electrolyte copper plus 2 ions are present. These here copper plus 2 will reduce it to copper metal. One more important point I want to discuss with you here. For example, uh, here through the voltmeter I am connecting. Then here if you see, zinc I am taking, copper I am taking, here zinc sulfate I am taking as an electrolyte. Here in the case of copper, I am taking the silver chloride as the electrolyte. What will happen? What is the anodic reaction, cathodic reaction? Please expect all of you. Many students, you will expect anodic reaction perfectly. That is, anode reaction is zinc gives rise to zinc plus 2 moles of electron. This is the reaction where oxidation reaction at anode. Okay, no problem at anodic reaction. When you coming to the cathodic reaction, what happening? What is the electrolyte here? Silver is the electrolyte. Please remember that silver Ag plus electron here gives rise to Ag metal. This is the reaction takes place here because of what I said to you. Here electrolyte will be reduced at the cathode, not electrode. Copper already it is in the zero state, so where the copper cannot be reduced further. What will be reduced? Suppose if I take copper sulfate solution, copper plus 2 ions will be present, that will be reduced. But copper plus 2 ions, I did not take the copper sulfate solution. Silver chloride solution I have taken. Then what will happen? Silver will be reduced. No copper is there. How it will be reduced? So it is not possible. Understand? So this is the reaction. This is the correct reaction. So to confuse you, suppose if I change the electrolyte, then depends upon the electrolyte only. Cathodic reaction will be there. Anodic reaction, it will not depends upon the electrode is here. Cathodic reaction only depends upon the electrolyte. Anodic reaction depends upon the anode. For example, yeah, if I change the anode, for example, I will take the aluminum, then aluminum will be oxidized to give aluminum will be oxidized rather than aluminum oxide, Al plus 3 ions will go into the electrolyte. So here electrode will be oxidizing. Here electrolyte is reducing. That point you understand and then keep in your mind. That is the very, very, very important point. You must understand and then you must